Good afternoon. We are going to do the notes for Unit 7, Day 4, which is writing cubic functions and finding upper and lower bounds. On this day of notes, we are not going to be doing any graphing. It's going to be all algebraic, so you do not have to use graph paper unless you want to. As always, a couple different colors of ink is usually a wise choice. Okay, Roman numeral 1, upper and lower bounds. Upper and lower bounds. Okay, so why do you care about upper and lower bounds? Okay, upper and lower bounds are rules, and basically what they tell you are if there are any roots or zeros below what you have or above what you have. So this indicates roots below or above the ones you have. And that helps, and what's nice about that is when you're using rational zeros theorem with that gigantic list of possibles, this can actually narrow your possible rational zeros list. The nice thing is it doesn't even require extra work. It just requires looking at what you've done and noticing the patterns. So it can help you out. Now, what do I mean by that? So let's say that you get a 0 at 4, and there's like 10 zeros bigger than 4, but only 2 zeros less than 4. If you run the test that says you have a lower 0, then you only have 2 options to test out instead of randomly picking out of the 10. It redirects your guessing for more accuracy. Okay, so the rules start out the same way. Let f be a polynomial function with a positive leading coefficient. Let f be a polynomial function with a positive leading coefficient. Okay, so if f of x is divided by the factor x minus k using synthetic division, and then here's your 2 rules. A, if your root k is greater than or equal to 0, and all numbers on the last line are non-negative, so that means that 0 is okay, and all the numbers on the last line are non-negative, then k is an upper bound, which means there is nothing above k that's a root or a 0, so that narrows your list down. Okay, B, the second thing. So again, if f of x is divided by factor x minus k using synthetic division, okay, if k is less than or equal to 0, and the numbers on the last line of your synthetic are alternately non-negative. Again, non-negative means positive and or not. Positive and 0 are both non-negative. Then k is a lower bound. Okay, so let's draw your attention to 2 important parts of this. You have to have a positive leading coefficient in your function. It doesn't work if it's negative. And then the zeros that you choose, if it's greater than 0, then you can do the upper bound test. If your root is less than 0, then you can do the lower bound test, but you can't use a negative number for the upper bound test. It has to be a positive number. And same thing for the lower bound test. You can't use a positive number for a lower bound test. So those are limitations that you have to be careful of. All right, we're going to do an example. Let's say that f of x equals 2x cubed minus 5x squared minus 6x plus 4. So of course you're going to do your p over q list. Factors of 4 are plus and minus 1 times plus and minus 4, and of course plus and minus 2, because 2 times 2. Factors of q, the first number, are 2, so plus and minus 1 plus and minus 2. All right, putting together our list of possible rational zeros. Start with everything over 1. 1 over 1, 4 over 1, 2 over 1. Now go to the 2's. 1 over 2 is 1/2. Now 4 over 2 is 2, and we already have that. 2 over 2 is 1, and we already have that. So those are our 4 possible rational zeros. Okay, so let's say that you pick 4, and you're going to divide it out. So you randomly pick 4 and use synthetic to see if it's a 0. So 2, -5, -6, and 4. 3, 2, 1, 0. Nothing to fill. We do synthetic, so bring the 2 down. 4 times 2 is 8. 8 minus 5 is 3. 3 times 4 is 12. 12 minus 6 is 6. 6 times 4 is 24. 24 plus 4 is 28. Okay, so what does this tell you? First of all, it tells you that x equals 4 is not a root, because it had a remainder. But 4 is greater than or equal to 0, so it meets that k has to be greater than or equal to 0. And if you look at the bottom numbers, they're all positive. So they're all positives, which means that 4 is an upper bound. There are no roots that are going to be greater than 4, either radical or otherwise. So even though the 4 didn't pan out, it does tell us that it's an upper bound and there's nothing above it, which is good to know. Okay, so we randomly pick another one. We're going to divide it out. We pick -2. So let's put the coefficients: 2, -5, -6, 4. Skip a line, draw a line. Bring down the 2. -2 times 2 is -4. 5 plus 4 is -9. -9 times 2 is 18. 18 minus 6 is 12. 12 times -2 is -24. Plus 4 is -20. Okay, so there was a remainder. So x equals -2 is not a root. -2 is definitely less than or equal to 0. And this alternates positive, negative, positive, negative. So it's alternating signs, which means -2 is a lower bound. Now in this case, what does that tell us? If -2 is a lower bound, then we know that -4 is not a root. We can pull that one off of our list. So sometimes when you really just can't, you got a really long list, you can't figure out where your roots are, just pick one in the middle. Pick a positive number in the middle, pick a negative number in the middle, and at least get an idea for where the roots are, and that will help narrow down your search. So it's kind of an interesting little theorem, and it doesn't really cost you very much work because you'd have to divide them out anyway to see if they were zeros or roots of the function. So it really isn't any more work. It's just using what you have to give you a little bit of bonus information. Okay, Roman numeral 2, and I'm going to flip the page here. Roman numeral 2, writing a cubic equation. Okay, so typically when you're doing this, they're going to have you write the equation from given zeros, and then sometimes they want you to have a specific leading coefficient. Just depends on the question. All right, so let's do an example. Example 1. All right, we're going to write a cubic with the roots radical 7, negative radical 7, negative 4, and then here's where the leading coefficient, and a leading coefficient of negative 2. That's our mission. Okay, so your first step, number 1, is to turn the zeros into factors. So x equals radical 7. You're going to subtract radical 7 over to the left, and you get x minus radical 7 equals 0. So that's our factor, x minus radical 7. Okay, x equals negative radical 7. We're going to add radical 7 over to the left. So x plus radical 7 equals 0, which means our factor is x plus radical 7. And then the last one, x equals negative 4. You're going to add 4 over to the left. You get x plus 4 equals 0. So x plus 4 is the factors. And again, these are the factors. These are the zeros. Really important to keep that straight. Okay. So then the second step is you write the equation in factored form. So f of x equals, leave a little space there, x minus radical 7, x plus radical 7, x plus 4. That's factored form. And then whatever they want for the leading coefficient, tag the leading coefficient at the front. So they want a leading coefficient of negative 2. We're going to put the negative 2 in the front. Now, if they ask you for the equation in polynomial form, basically get ready to multiply. Most people, when they do this, and no, I'm not going to do this today, they multiply negative 2 times x minus radical 7, and then they multiply x plus radical 7 times x plus 4. And then whatever they get from those, they multiply together. Makes it go a little smoother. Okay, example 2. This is an example where they're going to give you the roots, but they're not going to give you all of them, and they expect you to figure out the missing roots. So let's say that the roots that they give you are 6 and 2 minus 3i, and you're supposed to write a cubic equation. All right, so what they're expecting, you only have 2 roots. For a cubic, which is, x cubed, you need to have 3 roots. Remember the n roots theorem that says whatever the degree is, that's how many roots that you have. What they expect you to remember is that roots that are imaginary have imaginary conjugates. So if a plus bi is a root, a minus bi is a root. So as a result, your roots are 6, 2 minus 3i, and 2 plus 3i. Okay, last thing I want to show you, little algebra thing here, is how do you convert a binomial 0 to a factor? So I'm going to make a little box because I'm almost out of space here. let's say x equals, oh, that should be a 2. Sorry, 2 plus 3i. There we go. So let's say x equals 2 plus 3i, and we need to get a factor out of it. You're going to do the same thing as what we did up top. You're going to subtract everything to the left and make sure it's equal to 0. So x minus 2 minus 3i equals 0. And that is your factor. So you do it the same way. You take the 0, set x equal to the 0, move everything to the left, and that is your factor. So you're going to need to know that for your homework. All right, let's see. That is how you write a cubic using roots that you're given. Okay, Roman numeral 3. And I would definitely start at the top of a new piece of paper for this one. Roman numeral 3. We're going to write a cubic equation from data. Okay, so your example is you're going to write a cubic that passes through, and they might say passes through, they might say contains. They're going to give you some points. -2, 4, -1, 0, 0, 0, 1, -2, and 2, -12. They give you a whole bunch of points. Okay, so standard form of a cubic is something like this. Y equals ax cubed plus bx squared plus cx plus d. And in order to get the cubic, you need to find a, b, c, and d and get them into the equation. Okay, so what you're going to do is there are 4 unknowns, so you need 4 points. You need 4 points to figure out what this is going to look like. Now, you notice they gave you 5, so you get to pick your 4. A wise first choice is 0, 0, and I'll show you why. So we're going to take the point 0, 0, and since y is 0, this is your x, this is your y, so it is 0 equals, and then all the x's are zeros. So a times 0 cubed plus b times 0 squared plus c times 0 plus d. Well, the nice thing about 0, 0 is all of these cancel out, and I get d equals 0. So I actually got my first one. That's really nice because now I can eliminate d from the rest of my equations because I already know it's a 0. Okay, let's pick another point. I picked the easiest ones I can, like 1, -2. So y is -2, x is 1. So -2 equals a times 1 cubed plus b times 1 plus c times 1, which is -2 equals a plus b plus c. There's one of our equations. Okay, now we're going to do point -2, 4. X is -2, y is 4. So 4 equals a times -2 cubed plus b times -2 squared plus c times -2. Okay, so 4 equals -8a plus 4b minus 2c. There is our second equation. 3 unknowns, 3 equations. I need one more point. I'm going to pick -1, 0. Again, I like the easy ones. So x is -1, y is 0. So 0 equals a times -1 cubed plus b times -1 squared plus c times -1. I get 0 equals -a plus b minus c. Okay, so at this point, we have AB, we found D to begin with. If we didn't have D, we would need to do 4 equations and 4 variables. But since there's 3, A, B, and C, we only need these 3 equations. Okay, so we've made our new equations. Now here in the process, you actually get to choose how you want to do the rest of the problem. You can do linear combination or substitution to get your answer. And you get to pick whichever is your favorite. I'm a fan of linear combination. If I look at, and I'm going to call this equation number 1, equation number 2, and equation number 3. If I look at 1 and 3, you can see that the A's are going to eliminate, and I'll actually get what my B is. So that's a really good one to do. So I'm going to do equation number 1 and equation number 3. So number 1 was -2 equals A plus B plus C. Equation number 3 is 0 equals -A plus B minus C. Using linear combination, I'm going to add them up. I get -2 equals 2B. So B has to be -1. Now, once you get your first variable, what you can do is substitute that variable into 2 of the equations. One of them has to be number 2 because you haven't used it yet. And you're going to sub it in and create new equations. So this is new equation number 2. Replacing B with -1, I get 4 equals -8A plus 4 times -1 minus 2C. 4 times -1 is -4, so I'm going to add it over. So -4 plus 4, that will give me 8 equals -8A minus 2C. That is my new equation number 2. And then I get to pick which one I want to do. I like number 1. So I'm going to do new equation number 1. And I'm going to replace B with -1. So -2 equals A minus 1 plus C. Add the 1 over, I get -1 equals A plus C. Okay, so now I'm going to use linear combination and combine these, but I do need to make an adjustment because nothing at this point is going to add up to 0. So I'm going to take, let me change colors here. I'm going to take the second equation and multiply it by a +2. So that will give me -2 equals 2A plus 2C. And then I'm going to take number 2 the way it is. 8 equals -8A minus 2C. Draw a line, add them up. You get 6 equals -6A, and the C's add up to 0. So A must be -1. And now that I have A, B, and D, I'm going to substitute into an equation to get my last letter, which is C. I'm going to substitute A, B, and D into equation number 1. So -2 equals -1 for A, minus 1 for B, plus C. And it didn't have a D, so that's pretty easy. So -2 equals -2 plus C. So, C equals 0. Okay, now that I have A, B, C, and D, I can write my answer, filling those letters in. This is my answer. So f of x equals, now A is -1. -1 cubed is a -1, so -A. B is also -1, so minus, sorry, -A squared. Excuse me, gotta make sure that I actually input the A's and the B's and keep the X's. Okay, let's try that again. F of x equals, okay, so A is -1, so -x cubed. B is -1, so negative x squared. C ended up being 0, and D ended up being 0. So that is my answering function. Okay, so to recap, write a cubic that passes through specific points. You have 1, 2, 3, 4 letters, you need 4 points. Now, if 0, 0 happens to be one of them, you can do that one first and eliminate D, and then you only need 3 points. Pick 3 points, sub them in, get 3 equations. Then take those 3 equations and either use linear combination or substitution to solve them for A, B, and C. And these are all things that you did in Algebra 2, just probably not with this many variables. All right, that's the end of the notes. Have a good afternoon.